So good afternoon everyone. Myself is Dr. Ajit Kumar and I am faculty in the Department of EC at the Presidency University. So we will continue our lecture. Okay, so today we'll study about the different instruction set of 8051 microcontroller. We'll study the different categories of 8051 microcontroller and one by one. Okay, so we have different types of instructions here. Okay, the different categories of instructions are there. Uh, okay, so we'll see all these one by one. Okay, the we can see here we have different class of instructions. Okay, so 8051 instruction. So we'll see here different class of different categories of 8051 instructions. Okay, this set of instruction is actually having different categories. The first one is called data transfer instruction. Okay, the data transfer instruction is that kind of instructions which transfer the data from one place to another place. Then second category of instruction is arithmetic instruction. Arithmetic instructions are those instructions which are used to perform arithmetical operations. Okay, for example, addition, subtraction, multiplication, division. Then we have another category of instruction which is called logical instruction. When we perform and or XOR operation, okay, then we use this logical instructions. Then we have fourth category is called bit related instructions. When we try to do some operation on some certain bits, okay, that means one bit of data, then it is called bit related instruction. And the last category is actually the program branching instruction, okay, which is used to create a loop or iterate certain instructions, okay, multiple times. Okay, so we'll see these all type of instructions one by one. So let us start from the data transfer instruction. Okay, in the data transfer instruction, the very important instruction is the move instruction that we have already seen when we were discussing about the various. Okay, so here uh, we will study about the first category of instruction, which is called data transfer instruction. Okay, data transfer instruction actually is that those instructions which are used to transfer data from one place to another place. Okay, now we know that here. So let us assume that this is 8051 microcontroller. Okay, inside this we know that there are different registers like A accumulator, B register, then R0, R1, R2, R7. Okay, then we have some other registers like PC, SP, DPTR. Okay, these are other registers. Now we also know that there are two types of external memory chip, that is called external RAM and external ROM. Okay, so here the we know that these external RAMs and external ROMs, they are also used to store the data. Okay, so the data transfer means we can transfer the data from 8051 microcontroller to either RAM, external RAM, or from external RAM to 8051 microcontroller. Okay, we can also transfer the data from ROM to the microcontroller. Okay, so here we can only do read operation, so that is why it is one way. Here we can do read and write both. Okay, so in this case the data transfer will be in both direction. Okay, then we also know that there is internal memory chip. Okay, internal ROM and internal RAM. So this is RAM and this is ROM. Same thing here also. Okay, now when I was saying that the data transfer will be from microcontroller to the external RAM or microcontroller to with external RAM, it means actually here also you know that data transfer means it is going to transfer and get stored at some place. Okay, so where it is going to get stored in these registers only. Okay, in these registers. Okay, so here we have different types. I mean, where the data transfer can take place. Okay, between register to memory. Okay, register to register, memory to register. Okay, but you cannot do data transfer between memory to memory. Okay, between memory to memory, the data transfer cannot take place. Okay, this is not possible. That is, if you want to transfer the data, let's say this is your RAM, external RAM, let's say this is your address 1001, and let's say this is address 1000H. Okay, you cannot transfer data from one memory location to another location using any instruction directly. Okay, you can transfer by other means. Okay, in that case I'll show you. So this move instruction, okay, the first instruction that is used for data transfer is called move instruction. Okay, now the syntax of the move instruction is quite simple. Okay, we write the mnemonics move and then we have here two operand. Okay, this is called destination and this is called source. So the data always, okay, what happens here, the source data, okay, the source data goes into destination. Okay, this is the meaning of this instruction. Okay, so data from source will go in destination, but the source data will not be lost. Okay, the source data is not lost. Source data is not lost. Okay, so here destination could be your register, any one of the register. Okay, it could be your memory location. Okay, memory location. Okay, and this destination, okay, the destination can be your register. Okay, it could be memory or it could be immediate value. Okay, immediate value. So here we have data transfer will take place between, okay, that is you can have various case. Okay, you can have here move between register to register, the source and destination both will be register. Okay, this is destination D, this is source D. So your data can go from source to register, that is register to register. Example, you can write move A comma R not. You can write another example, move R1 comma B. Okay, these are your register to register. Okay, register to register. However, you cannot use here. What is the exception is, the exception is that you cannot write move R1 comma R2. This is wrong here. Okay, why? Because, or you can in general, okay, in general you can't move the data between any register Rn, okay, and Rm, where n is 0 1 2 7. Okay, that is you cannot use the registers R1 R1 R, I mean you cannot transfer the data between any one of the registers like R0 R1 R2 R3 R4. Okay, it is actually why it is happening, because if you remember these registers R1 R0 R2, okay, this, suppose this is your internal RAM. Okay, so we have already studied that in internal RAM, here this, the starting address is 00H. Okay, 00H, which is actually designated by register R0. Then the next address is 01H, which is designated by register R1. Okay, like this, R7, sorry, 07H, which is designated by R7. So just now I told you that you cannot move the data from one memory location to another memory location. That is, okay, you suppose something is there like 04H. So and you want to move this 04H from this memory location to this memory location. In that case, you can't do this using this instruction. Okay, that is move. Okay, uh, can you tell me what is source and destination? The source will be this address, okay, and the destination will be this address. So you cannot write this here D and source as both memory address. Okay, this is wrong. This is wrong. Okay, to transfer it from one memory location to another memory location, you have to use it in different manner. Okay, what you will do is you can be using something like this. You can transfer this data in, let's say, register A, and from A you can move this into this memory location. That is, first of all, you can write something like this: move A is destination, what is source is 00H. Okay, step 1. So in this manner, A will be the data which is in this memory address 00. So A will be 04H. Then you will write the next instruction, move. Now the destination is this one. This address is destination and this is source. So this you write as 01H comma A. So it is going to happen, the data of A will go in address 01H. Okay, that is 01H address will now contain 04H. So this is how you can transfer. Okay, so remember that using move instruction you can transfer the data from source to destination, but both cannot be the register RM or RM. Okay, so this was the first example that you have taken here. Remember what I said. I said that your destination can be your destination can be register, memory, and source can be register, memory, or immediate value. So register to register I have seen. Okay, this was a register and this was a register. So likewise you can have different combinations. You can have destination as register, you source as memory location. Okay, okay, so just here if you see move instruction, okay, any register, so you can take any here any register, and here you can take any memory location. This is source, this is destination. For example, suppose that this is your memory chip. Let's say this address is 04H, and here let's say some data is there 43H. Okay, and suppose that this 43H you want to move in the, let's say this is internal RAM, and this one you want to move in the register A, which is also the part of microcontroller. Okay, so in that case you will have to write this instruction, move. So just write here destination, here write source. Now just see here what is source is this address from where you are transferring the data, because in this address only your 43 data is stored, and what is destination is this one. Okay, so I'll write the source as 04H. Okay, this should be copied into the register A, which is destination. Okay, so you can take register as destination, memory as source. Likewise, suppose that this 43 you want to directly move in the register A, so you can also use this one, move. Now A is destination and this 43 is your source, so you can write directly move A comma. Now you want to move this 43, which is constant data, and if you remember here, to show this as constant data you will have to put this pound sign. Okay, that is pound 43H. Okay, so this means this is data. If you don't place any hash sign, then this indicates memory address. Okay, so you try to understand the difference between these two. Okay, so in this case, what is the meaning of this instruction? Move the data. Okay, move data from memory address 04H to register A. This is the meaning of this instruction. Whereas what is the meaning of this instruction? The meaning of this instruction is move the data. Okay, the meaning of this instruction is move the immediate data. Why it is immediate? Because the data is not available in register or memory location, but it is immediately available in the instruction. So move the immediate data 43H to A. Okay, this is the meaning. Okay, so like this you can have different combinations. Okay, that is I have used here immediate value in, and here I have used register. Okay, but you cannot have, always remember one thing, that when you are using move instruction, this destination should be always memory or register. You cannot use here immediate value, because you know this should be some storage device. Okay? Storage okay, place, and you cannot move the source into immediate value, because immediate value is some constant value. Okay, however, remember here source was also memory, and it could be register or it could be immediate value. So what is the exception is that you cannot take the memory and memory both here. Okay, you cannot write move memory address as destination and memory address as source. Okay, this is not correct. Okay, because there is exception that both cannot be memory address. Okay, so I already explained you that how you can move this value from one memory address to another memory address. Okay, first of all you have to transfer the source memory address data into some register, and from register you have to transfer into destination memory address. Okay, now this move instruction, always remember that this move instruction is used with internal ram, internal ram. Okay, internal ram chip. That is though it, you can transfer the data between the register to register. Okay, but here you know that this is your microcontroller 8051. Inside this microcontroller 8051 you have ram, which is 128 byte. Okay, you have rom, which is 4 kilobyte. Okay, so when you are going to use move instruction, okay, you know this is again having destination and source. So here I said that this could be memory address, this register or memory address, or this could be memory address, register, or immediate value. So when I'm saying, when I'm talking about this memory address, then this memory address is actually the memory address of ram. Okay, this memory address is of ram, of internal ram, internal ram. Okay, remember this is very important point. Okay, that is when you are using this ram, internal ram, then suppose this is the address 04h, and if any data is there and you want to move this data into register A, okay, then you have to use move instruction. Okay, you cannot move. Now what about the another thing? So now this was applicable for the ram. Suppose I want to move from this rom address, okay, from some rom address here. So in that case what I'll do, I will be using another instruction which is called move C. Okay, so there is another instruction which is called move C. Okay, C stands for code memory. Okay, code memory, and you know this code memory is actually ROM chip. ROM chip, either internal or external. Okay, so what is my point is, suppose this is your microcontroller 8051, and here you have this ROM which is 4 kilobytes, or and we have also another external ROM. Okay, external ROM is also there, which is also called program memory. Okay, this is external ROM. So either internal ROM or external ROM. Okay, so for transferring the data, okay, let's say you are writing here in let's say register A is there, and you want to transfer the data from this memory address. Let's say this is the memory address of ROM. You know, let's now this ROM is actually 4 kilobytes, which is not sufficient. Okay, so that's why we connect external ROM, which could be 64 kilobytes. Okay, so if you want to transfer from this internal ROM memory location or this external memory location, Okay, so suppose some data is there in that one. That data is basically the code only instruction. You know that these ROMs are going to be yours to store the program. Okay, so whenever you write the code, that for a summation or I mean multiplication, division, whatever program you write in ALP, no, that gets stored in this internal ROM. If it is not sufficient, then the it will be getting stored in the external ROM. Okay, so here this is of 4 kilobyte. So the starting address of this one is 000h to 0FFFH. Okay, and this is 64 kilobytes. So the starting address is 0004h and it goes up to FFFH. Okay, so when you are trying to transfer some data, let's say into register A from this memory location, let's say this is 004h and let's say this address is 008h. Okay, so in that case you will have to write something like this: move C. First of all you have to write move C. Now for the move C, the syntax is fixed. Okay, here the syntax is fixed. You cannot take the source and destination as per your wish. Okay, so in this move C, the syntax is actually move C a comma at the rate adptr. Okay, so always remember when you are using move C instruction, the this one this destination should be always a and this source should be a plus dptr. Okay, at the rate dptr. So what is happening, this at the rate dptr is actually when you write at the rate, okay, at the rate a plus dptr, the meaning is that it is memory pointer. It is memory pointer. When you place this at the rate sign, this becomes memory pointer to some address, memory address. Okay, let's say you want to transfer the data from external ROM, which is whose effective address is this one. Okay, this effective address. Now how this effective address you will get? You will get this effective address by adding the base address. Let's say this is the starting address 000h. This is called base address. Okay, and this base at, I mean you can see 008 is actually located at the separation of 8. Okay, so when you will add base address with this 8, which is called offset, you will get this effective address. So you know this effective address will be equals to base address plus base address plus offset value. So you see the base address is starting address 000h plus the offset value is 8, which will be 00008h. Okay, this is effective address EA. So what I'll do is to move the data from this address 008 into this what is this A register. Okay, so I'll write here something like this: move. Okay, first of all what I'll do is you'll have to load this value 000, which is base address, into the dptr. So you'll write here dptr 000h. So what is the meaning? Now you cannot write directly this one, otherwise the meaning is moving the data from memory address to this one. So you'll have to place compound pound sign. Okay, generally I call this hash in for the easy understanding. So this dptr value is now dptr is holding the base address 00h. Okay, and then you will move the offset value into register A. So what is the offset value? 08h. Okay, so here A becomes 08h. Okay, now you will write something like this: move C A comma at the rate A plus dptr. So this A is 8 plus dptr is 00h. So this, okay, is actually pointing to the address 0008h. Okay, why it is pointing? Because we have written here at the rate. Okay, so the meaning of this instruction is, what is the meaning? Move the move the data, basically code instruction, okay, from memory address 000h point, which is pointed by a plus dptr, and where to move to a. Okay, this is the meaning of this instruction. Okay, so likewise, if you want to transfer the data from this internal rom, okay, any data is there in that address, let's say 004h, so same way this will be pointed by a plus dptr, and then the data which is in this address 004h will be transferred to this register a using MOVC. Okay, so you'll have to write here MOVC. So this MOVC is used for the code memory, okay, that is ROM. Fine. Then we have another one which is called MOVX. Okay, so for the MOVX we have another one which is called MOVX. Okay, this instruction is used to transfer data, okay, with external RAM. Okay, see, this is your microcontroller 8051. Okay, so this is 8051, and then we have seen that there is ROM. I'm not drawing the ROM is over, so I'll draw external RAM. And suppose that there is some data in this external RAM, and this address is there. Okay, this address, memory address. So what I'll do is I'll have to use MOVX instruction, and again the syntax is here same or fixed one. Okay, the syntax of MOVX is fixed. Syntax is, you will have to write here MOVX. Now between the RAM and the microcontroller, here the data can go in this way also, that is by write operation. The memory microcontroller can store something or overwrite this existing data with a new data. Okay, or this data can be brought inside the microcontroller, so here read and write both can be done. So here MOVX, and the syntax is a comma @ dptr, where this dptr will point to this address. Okay, so the data from this is source, this is destination, so data from the memory address pointed by dptr will be shifted into register a. Okay, now this is actually a read operation where the data is being read from the external RAM. Similarly, vice versa, the microcontroller can also transfer data. Okay, or you can say do the write operation. So I'll write a here, and I'll write here @dptr. So the data will get copied into memory address pointed by dptr, from where, from a. So data will go from a to this address which is pointed by dptr. Okay, so this is MOVX instruction. Okay, here we also use another one. Okay, @dptr is there, you can also use @r0 and r1 also. Okay, that is MOVX a comma @r0, okay, or @r1. So the data pointed from the data from the memory address pointed by r0 or r1 will go in register a. For, or you can have vice versa, that is @r0 or r1, and here from a. Okay, so vice versa. So this is also correct, we can use r0 and r1 register also. Okay, so this was actually move instruction. So using move instruction, you can move the data from source to destination. Okay, then we have push and pop. This push and pop instruction I have covered, okay, when I have discussed this topic, addressing mode. Okay, so I'll not discuss this one. Then this is actually DEC is not data transfer instruction. Okay, neither this multiplication division is also not data transfer instruction, but let us try to understand this decrement, multiplication and division instruction. Okay, so decrement instruction is quite easy. Okay, DEC, which the full form is decrement. The, as the name suggests, it is going to decrease the value. Okay, it is used to decrease the operand value by 1. Okay, and here the syntax is DEC. You can have register slash memory. Okay, so example, suppose that I have written here move, let's say R0 comma has 0 to H. Okay, and if I write here DEC R0 as per the syntax. Okay, so what is the meaning? The meaning of this one is the new value of R0 will become previous value of R0 minus 1. So what is the previous value of R0? It is 0 to H. Okay, subtracted by 1. Okay, so your new value R0 will become 1. So after this instruction, the value of R0 will become 1. And suppose that you have written another DEC instruction, DEC again R0. So again R0 will become R0 minus 1. So the previous value of R0 was 0 1 H, will be subtracted by 1. This is the updated new value of R0 will be 0 0 H. Okay, so again after executing this one, the R0 value will become 0 0 H. Okay, this is DEC instruction, quite easy. Then we have another one, just opposite to this one is INC. Okay, INC. Just opposite to this DAC, we have INC, which will increase the value of any register or memory address by 1. Okay, so here I said that you can have register also, memory address also. Okay, for example, suppose this is your RAM address 01H, and in this address let's say 04H is there. Okay, so what I'll do, just to explain this one, let's say I'm writing here this instruction move. Suppose that I've written here move. This 01H is destination, which is memory address, and this is the value. Okay, so what is happening after writing this instruction, this memory address 04H will now store 04, and let's say I've written here DEC instruction, DEC this 01H. Okay, so now this 01H is the memory address whose value is 04. So after executing this instruction, the value of this 01H memory address will become 03H. Okay, this is how you can do this operation on memory address data also. Okay, so just opposite to this one is INC instruction. INC, so INC means increment. Okay, increment, so it is going to increase the operand value by 1. Okay, example, and again here also same. What is the syntax? INC, you can have here the operand as register, or you can have memory address. Okay, both you can have. So let's say suppose that I have written here instruction this one, move R2 comma has 04H, and if you write here INC, now as per this syntax I can write R2. Okay, so the meaning of this one is R2 is equals to R2 plus 1. So after executing this instruction, the R2 will become 04 plus 1, that is 05H. This is the updated value. Okay, suppose that you have written another INC R2. So again after executing this instruction, the R2 value will become 05 plus 1, 06H. Okay, this is how the INC DAC instructions are used to increase or decrease the value of operand by 1. Okay, then we have another instruction. Okay, that is multiplication and division. Okay, MULAB and DIVAB. So that actually MUL should be have in the this instruction. Okay, that is in the arithmetic instruction. But anyway, let us try to understand this MUL. MUL means multiplication. Okay, it is used to multiply the two numbers. Okay, and the two numbers, multiplication of two numbers. But here the rule is that these two numbers should be in register A and B. Okay, suppose that you want to multiply 10 with 4. So this 10 should be in the register A, this should be in register B. Okay, then you can write MULAB. Okay, and what is the syntax? The syntax is MULAB. Okay, MULAB. So you can multiply the value of A and B, and after multiplication, the product is saved. The product is saved in such a way that lower byte is stored in register A, and upper byte is stored in register B. Okay, so let us try to take one example here. Suppose that I want to multiply the previous case, 10 into 4. So 40 will be the result. Okay, so what I'll do, first of all, I'm going to store this 10 in either register A or B. So let us store in A, this in register B. So to store this one, you'll have to write here move A comma hash, because I'm considering this as decimal number, so I'll not write H, I'll simply write 10. Okay, and another one 4 I'll store in the register B, so I'll write here move B as 4. Okay, now I'll write here as per the syntax MULAB. So you know that your product is 40. Now this product will be saved. Okay, now let us try to convert this decimal number into hexadecimal number. Okay, so this 40 I'll divide by 16. So 16 to the 32, 8. So this one is quotient, this one is remainder. So your QR value is 28, and this is your hexadecimal value. So I'll get here 28. Okay, now this 28 is 8 bit, or 8 bit is, that is 0010. This is 2, and what is 8? 1000. So this is actually the lower byte. Okay, upper byte is by default 0. Okay, so this 28 I can write something like this, because when you see here, let's try to understand why I'm getting this concept of upper byte, lower byte. Suppose that you are multiplying 2 into 8 in the decimal, so you are getting the product 16. Now you can see this is a single digit, this is a single digit, but this is double digit number. The product is double digit. Similarly, when you are going to multiply 8 bit into 8 bit, because in microcontroller these things are getting done in the binary form, the product could be your 16 bit. Okay, so in that case, this 16 bit, okay, this is we have here 8 bit, 1 2 3 4 5 6 7 8, and upper 8 bit 1 2 3 4 5 6 7 8. Okay, so this lower byte will be stored in the register A, and this upper byte will be stored in the register B. This is the protocol. Now after multiplication I got 2 at H, so 2 at is here, and here I'll assume 0. Okay, so 0 will be stored in the register B, and this 2 at will be stored in the register A. Okay, so after multiplication of this, okay, after multiplication, what I'll get is A value will be 2 at H, B value will be 00H. Okay, so you have to remember this. Okay, answer. So you can take any other example also. Okay. So now similarly we have another instruction which is called div. Div means division. So in the division instruction, we divide the numerator by denominator. Okay, we have two things in the division: numerator divided by denominator. Okay, this numerator is also called dividend, and this denominator is called divisor. So always remember that when you are going to divide two number, the dividend okay, So here I will just talk about the syntax. The syntax is again fixed. You cannot divide by any way. The syntax is div ab. So the meaning of this instruction is a is divided by b. This is the meaning. Okay. So in that case, you this dividend will be always in the register a, and the divisor will be always in the register b. Okay, this you have to remember. Now after division, okay, you know this is a being divided by b, so you will get two things. Here you will get remainder, and here you will get quotient. Okay, so again remember one thing, the quotient will be saved in register a, and this remainder will be saved in register b. Okay, this also you have to remember. Okay, so just we'll take one simple example, then we'll understand. Suppose that we have to divide 95 by 10. I'm taking decimal number system. So you know 95 is going to be divided by 10. So you'll get 10 9 90. 5 is the remainder. So after division, okay, this quotient will be saved in the register A. This remainder will be saved in register B. Also, this is after. Okay, and this dividend is supposed to be in the register A, and this divider should be in register B. So to implement this 95 divided by 10, okay, you have to write it like this. Move register A, which value 95. Now this is decimal number, so no need to place hash. Move B hash 10. Then you are going to write div ab. Okay, so this is the program for the division of 95 by 10. And after division or after execution of this instruction, the value of a will be 9 and the value of b will be 5. This is the answer. Okay, so this is this multiplication and division which I told you right now is actually for the unsigned number. Okay, so we have two types of division and multiplication: signed multiplication division, signed unsigned division. Okay, and then so we'll stop here. Okay, we'll start our next class in the next day. Tomorrow we'll start our next class. Thank you everyone.